everyone, and welcome to the next game programming tutorial. Today, we're going to be doing stuff with sprites. We're going to maybe do some map movement stuff, I don't know, tile stuff. We're going to do a lot of cool stuff this episode that'll get you guys jump started. And actually, this episode's really when we're really going to get into making games and not just graphically generating things. So that's pretty cool. So last time you had a challenge, and that was to render this, well, not just generate the graphics for this rectangle. But the catch was that you couldn't just generate the entire rectangle. You had to just generate each border of the rectangle. So the two parameters here were border width and color. And you needed to create a rectangle with that specific border width. And what we left off with was just the top part of the rectangle. I gave you that. And that was simple. That was just y is less than border width, and that's the first for loop. The next nested for loop is just the entire width, and that's when we stop. It's just the just until border width is done. I'm gonna turn on the microphone a little bit. You might hear a little bit of background noise, but I don't want it to be too quiet. So, so anyway, let's move on. Let's go ahead and create our next for loop here, because okay. So yeah, I'll give you a little hint for the challenge. So we're gonna need lots of for loops. And pretty much all of the for loops. In fact, all of the for loops are going to start exactly like what I have so far. And then the next part's what's going to change, right? So for this next one, let's say I want to render. Let's just render the left side, right? So for the left side of this rectangle, which by the way, if you don't know what a rectangle looks like, shame on you. No, I'm joking. If you don't know what a rectangle looks like, here's a rectangle. And as you can see, it is not full. What we had before was we had a solid color rectangle. What? I thought that's what that did. We had that. We had that last time. We want to get this. We just want to get the a rectangle without a filling with a specific border width, right? So that's what we're trying to do. So anyway, y is we're gonna go ahead and start with the height. So this is going to repeat for every single y level, right? Because we're trying to get this left side of the rectangle in. And then the next nested for loop is going to be x, and x is going to be less than border width, okay? And then pixels of x plus y times width, that's going to be the same, equals color. And then we need to change that back to that. And then if I run this, we should get the left side of the rectangle there. There it is. So there's that part of the challenge. See if now that I've told you this and you have both of these examples, see if you can figure out how to do even just the right side of the rectangle. That's a little bit more difficult. And the bottom of the rectangle should be easy. So if you want to pause the video and try that out, I definitely recommend doing that. Doing this code yourself without my help is definitely the best way to learn. So try just pausing this video and getting the right side and the bottom of the rectangle in. And I'm now going to continue and tell you what you should be doing. So as I said, this is pretty much how all the for loops start. All the first of the nested for loops, I should have said, but yes. So what should we do? Let's do the bottom of the rectangle. So y equals 0. Y is less than. Oh wait, no. So yeah, I'm gonna do the. I'll actually do the right side of the rectangle first. So we're gonna go ahead and do the right side. And then we'll do the bottom last, because this is actually a little bit less confusing. So for this one, what we have to do is we have to set x equal to width of the rectangle minus the border width, because we want to start a border width off from the very right side of the rectangle, because that's where we want to start placing our pixels. And then what's going to do, x is less than the actual width of the rectangle, and x plus plus. And then same thing we had before. And that should give us the right side of the rectangle. There it is. And now we're going to go ahead and do the bottom of the rectangle. Now this is actually, to be honest, this is all pretty simple. This is, it's just a whole different new way of programming for a lot of you, I think. But for this, we want the y to be equal to the height of the rectangle minus the border width. So, I mean, it's kind of the same concept we had here. And then y is less than the height, y plus plus. And then the next nested for loop is pretty simple. X is equal to 0. X is less than width, x plus plus. And then pixels x plus y times width equals color, just like we had before. Let's see if that works. There we go. So now we've got a rectangle that we generated that is not solid. It just has the border. We can change the border width to whatever we want. Let's go ahead and try testing this out. By the way, if you missed this, go ahead and pause this. Actually, I won't. Don't pause it. Just I'll give you a second here. So what we have going on here is we got the top part. The top part was definitely the easiest. Then we had the left side. Then we had the right side. And then we had the bottom. So you have to kind of split it up into 4 different parts. With all the concepts pretty much being the same. So anyway, we can do this with actually a bigger rectangle as well. If I try to border width of like 20 or something, this would still work. So here we are there. That's like a border width of 20. So yeah, any border width works. And you still got the same rectangle now. The problem is that you're probably noticing is it's currently covering the tile before it, right? It's completely covering that tile. It just doesn't give a crap about that tile at all. It really doesn't. It's like, you know what? I've got my own pixels. You can not have your pixels because I have pixels and they're at the same place you are. So anyway, long story short, we're gonna do some sort of thing with transparency here so that we can render this rectangle and not have it cover over everything below it. So what we're gonna do is we're going to go ahead and implement some alpha here. Now, you might be thinking, oh, alpha, that's got to be ridiculous to implement. Not really. The easiest way to do this with the system we have, and to be honest, like you might say this is the easiest way out. Maybe it is the easiest way out. But it's also, why do something that's more complicated if you can do something that's simpler and just solves the same purpose? So pretty much what we're going to do here is we're going to choose a color. We're going to choose a color that we are never going to use in any texture, any sprite ever, okay? It's going to be one of those stupid colors that just nobody ever used. Like I would use something like you can choose whatever you want. I would use something like a light yellow. What I'm going to use is this magenta color, right? And this is FF00DC. So I'm just going to go ahead and copy that. You can use any color you want. You can use cyan. You can use whatever you want. In fact, I think I used cyan in my notes, but let's go ahead and use FF00DC, I mean. I think maybe it was that one that I used, actually, the hot pink. Because that's kind of like a magenta, but you could use a hot pink or something, because who wants hot pink in this game? If you're making a Tetris game or something, maybe you want to pick like a color that you wouldn't ever use. I don't know. Just pick whatever you want. If you never want any black in your game, there's no reason why you couldn't just use the color black. But anyway, I'm going to go ahead and copy that. And what we're going to do is we're going to make something called a static variable, right? And this static variable, it's a static field, actually, to be more specific. So we're going to need public static int alpha, right? That's all it's going to be, is equal to, it needs to be 0x ff00dc, because that's how you put hex into the game. So that's going to be our alpha color. Now, the reason that we are using a static variable is because, okay, so some of you might not have learned static before, but what static does is it creates a variable or a method that can be accessed without even creating a game, right? Without even having an instance of game as an object, you can still have access to this method. So from anywhere else in any other class, we can do game.alpha, and this variable will still exist because it's static. It's kind of like a public, right now this is kind of like a public field that can be changed. It's a public field that can be changed, but it's just, you know, it's a public field that doesn't have to have an object to be created. I like to think of anything that's static to be part of some completely separate static class that holds every static object and it doesn't really like care about you having a copy of this at all. You might be saying, well, if that's the case, why don't we make everything static? And there are people that are extremely frowned upon. But yeah, you can't just make everything static. It just won't work out well for you. You'll have everything, or all the organization that Java gives you just goes straight out the window. So definitely don't do that. But we're going to make this static, and this is going to be our color ID, color, I guess, integer that represents alpha. So now, how do we implement this with images? You might already know. You just kind of like fill in that color in the picture, and it won't render it. Now, how we do this with rectangles is actually almost even simpler. all we really need to do here is we need to go ahead and run through every single pixel before we do any of this border width stuff, and just set it to the alpha pixel. So I is less than, we want to do pixels.length here. and then I++ or index++, whatever you want. And we're just going to do pixels I equals game.alpha. Now, if you're getting a static field from an object that doesn't exist, or just kind of an identifier, you want to use the capital G because this is a static field. We don't actually have a game instance here. We don't have a game object that we're dealing with. In this class, like, this has no access to anything. Like, we don't have a game, right? We don't have a game variable like that. All we have is the static field from game. So that's what we're getting here. So what that'll do, if we go ahead and compile the whole project, is that will fill in our rectangle with that terrible pixel that nobody ever wants to see. And then you see a little bit of a border there. Now really all we have to do now is something extremely simple, and that is to go to render handler, go to where we set pixel, and then we have, right now what we have is we're getting the pixel index, I guess. Oh, hold on, let me think here. Yeah, pixel index. So all we need to do is add another clause on this if statement to make sure we're not out of range that says and if pixel index, or sorry, no, actually it's just if pixel does not equal game.alpha, then we set the pixel. So if we go ahead and compile that and run, as you can see, our rectangle is rendered over this green thing, the tile, and we're not getting, it's not oversetting those, replacing those pixels, what I mean to say. So pretty much, it's a way of getting out of dealing with an actual alpha channel in your game. And to be honest, it's you know, for our purposes, unless you want to have transparency, like half transparency or stuff like that, it's a good way to get out of it. There's no reason why we need to mess around with that kind of stuff if you're not planning on doing it. Now, if you are planning on have some sort of transparency in your game, I have dealt with that kind of stuff before. What I prefer doing is actually making a separate layer for all of that kind of stuff, than dealing with, and then maybe when you're actually getting to the rendering, you can deal with transparency there. Like if we go to here, render graphics.draw image, you can actually draw image with transparency as well. So that's what I like doing. I like using Java to deal with that kind of stuff. If you're dealing with like half transparency or stuff like that. But for right now, that's all we're going to deal with. So that's cool. We now have transparency in our game, which we can use in any image or anything we want, which is pretty awesome. As long as we don't use this terrible hot pink pixel. But I mean, maybe like, I don't know, Hello Kitty game wants to use or something. I don't know, whatever you want to do. Okay. So anyway, now let's get into the nitty-gritty of this episode, and that is going to be sprites and SpriteSheets. So yeah, let's get rid of that. So hopefully this image gets you a little bit excited. This is kind of what our tile set is going to look like. We're going to turn our graphics that we have into a game. That's apparently what I decided on doing. So yeah. So sprites and SpriteSheets. We have sprites and we have SpriteSheets, right? Sprites, all that is holds an integer array of pixels for the sprite image. So we already kind of have that with our loading image method and stuff like that. We're gonna make this a little bit more advanced though. It also holds fields for the width and height of the sprite. It's not actually a buffered image. Like, that's the thing. It's just an array of pixels and the width and height of the sprite. Okay. And we have the render buffered image, and we'll also have a render sprite. It's gonna be a very simple method actually. And now what SpriteSheets are, what it's going to do is going to hold an integer array of pixels for the entire sheet image. Okay? It holds an array of sprites. And these sprites are loaded based on image size parameters that we pass in. So let's go ahead and talk about this. For some reason I closed the workspace. Let me go ahead and get back to that. Alright. So first of all, we need to get ourselves a sprite sheet. And I actually, if you have your own sprite sheet, that's fine. I also provide a bunch of stuff online. If you go to my website, which is marcusman.com right now, unless it's something different, check the description. I'll let you know if it's different there. I have to connect to it this way because that's kind of how I have to do it since I'm on the same network. You can go to the assets folder, and I have two things here. I have public domain assets, and I have used in lessons. The ones that we're going to use in the lessons are these two sprite sheets that I'm going to use for these lessons. Maybe I'll add a few more later, I'm not sure. But right now, these are ones that I got free online, and the credit's right here if you want to give anybody credit for these. If I remember correctly, I'm pretty sure the licenses are public domain. If not, you just need to give credit. Yeah. I think for this one, you need to actually just give credit to them. So yeah, these are the sprites I'm using. The credit is given on this page, and if for some reason my website goes down in many years, I'll go ahead and put the actual credit in here. Art by Charms, Carlos, or whatever, and yeah, all those people made the art. So there you go. What else do we have going on here? So on my website, we also have public domain assets. All of these, I think the worst license I able to find. Pretty much I compiled a ton of different assets from online. We have sprites here. Now we have this is like a roguelike set of sprites. Now this is Creative Commons 0, which means completely public domain. You literally can use it for whatever you want, which is pretty awesome. And this is actually this is a lot of sprites. Hold on. This is a lot of sprites, but it's also too much to deal with when you're just getting into stuff. Like, look at all this stuff. This is way too much to deal with where we are right now. The small little sprite sheet we have is way more than good enough. But they do give you a little sample of what kind of stuff you could make with these sprites, which is pretty awesome. And I do give, there's license here, and I make sure to, give credit to everything, even if it is public domain in here. Now, glitch license. There's a story behind this one. This is actually a very sad story. There's a bunch of game developers online that collaborated on this game. It was actually an actual game design studio, and it was like a dream game. It was everything they wanted it to be, and unfortunately, it didn't last. Well, it lasted for 3 years, but it just wasn't viable. The people didn't really like playing it. I think there were a good amount of people that liked playing it, but it wasn't like made for the society that for the real gamers of this time period. So it's a sad story. You can read about it here, but they had to shut down everything, pretty much, and they just released all of their sprites, all of their assets. So there's just a giant collection of their game's assets here that you can use in its complete public domain. From what I remember, you might want to check out that license though. And if you just go through some of these, it's actually pretty awesome. They have some really cool stuff in here. Like they have this thing here. I think the Batterfly. This thing took so long to make. You just know. That looked like it was a cube one. That wasn't really the one I was talking about. Let me see. NPC. They have a bunch of NPCs here. They have the Batterfly. Yeah, here it is. Look at this. I mean, how cool is that? And these are all sprites that you can use for free if you don't have your own. So that's pretty awesome. Now, if I go back here, there's just tons of stuff. So that you can browse through this kind of stuff on my website. Pick out what you want to use. Make sure you look at the license. What else do we have? Audio here. Now, this is actually a specific license you're going to have to read before you use any of this. This is a little bit different than the other one. But nevertheless, you can use this stuff as long as you give credit, from what I remember. But just read that license anyway. There's a lot of different assets in here that we can use. A pig. There we go. There's just tons of different audio assets as well. So yeah, it took me a good while to compile this stuff, and I'll try to add some more stuff in it if I find anything big online that you can use. So yeah, that's where I'm going to get all this stuff from. But let's go ahead and download the tiles we're going to be using in our case here, or you can go ahead and use any sprite sheet that you want. What I did is I just saved tiles1.png to my workspace. And that's just this here, just the sprite sheet with 16 by 16 sprites. There is no padding in between the sprites. They're all put right next to each other. And this right here is a sprite sheet. And it's a very basic sprite sheet. It allows us to do just a few different things. As you can see, the grass tile we used earlier was right there. And then a little bit more of a messy grass tiles below it. So, yep, we're going to be using these things. So, anyway, let's get out our code again. And let's get started with sprite sheets. Hold on a second. Shoot. Hold on a second. Be right back in a second. So we're going to have to create a new class here and call this SpriteSheet.java. And this is going to be our sprite sheet, which I talked about. And if you remember, sprite sheet holds an integer array for the entire sheet image, holds an array of sprites, and these sprites are loaded based on image size parameters. So we're going to just get the basic stuff in here, and then once we get the sprite sheet class working, we'll implement a few more things. So just like we start any old class, public class sprite sheet, and I'll go ahead and do that bracketing method for this one. As long as you're consistent, I think I'm trying to get consistent with it. I'm so used to the C-style brackets. So pretty much, let's go ahead and what I like to do to figure out these kind of classes is I like to create the fields before anything. So what we learned is that we need an array of pixels for the entire sheet image. That's public integer array of pixels. we also have, I mean, in order to get these pixels, we're going to need a buffered image, unfortunately. So let's go ahead and do private buffered image. So let's go ahead and import that now that we've created a method for, or sorry, a field for it. So let's import java.art.image.bufferedImage. And then pretty much I think the easiest thing for us to do is just going to have two fields for the size of the image and the size, well, the two fields for the size. So size X and size Y, width and height, whatever you want. Now, the reason I put these in all caps is I want to do something kind of cool with this. I want to go ahead and make these final, right? So final pretty much means you set these once and you can't change them. Okay, this is kind of just something that's kind of like to make sure that no stupid problems happen with the game, because the worst thing to happen in your game is that you're having so many problems implementing graphics, and for some reason suddenly all of your tiles are in the wrong spot on the game, and it could be because of the sprite sheet class. So you just want to eliminate any of that happening by setting the size and the X and Y as we load the sprite sheet. Okay. So you can only set final variables once, pretty much. And then we can either set them up here or when we load. But what we're going to do is we're going to actually do this in the constructor. But if you don't set those in a constructor, you'll get an error. So if I tried... this is kind of going to be our constructor, by the way. We're going to have public sprite sheet, and we're going to take just an image. That's all we're going to take. Just a image for the sheet that is loaded in the game. So now if I went ahead and compiled this, we'd get an error because variable size X might not have been initialized, and this is a final variable which is needed. So let's go ahead and do that. Let's go ahead and set those. Size X is going to be equal to sheetImage.getWidth, and then size Y is going to be equal to sheetImage.getHeight. Okay, because that's the size X and Y of the sprite sheet. Once again, the reason it's in all caps is because it's kind of just something you do when you have final variables. You can put them in all caps. Oh, another thing, we can actually just set image equal to sheet image. So that sets that field. So now what we want to do is we want to copy all the pixels from the sheet image into our pixel array. Now, the reason why we're not going to go ahead and I'm going to do something different here than we've normally done before. What we're going to do is we're going to go ahead, instead of getting the data like buffer, like in render handler, what we did here is we got the raster and the data buffer and the data for the pixels. We're not going to do that for this sheet image, just to make our lives a little bit easier. So we're going to go ahead and set pixels equal to new int size X times size Y. And what we're going to do is we're going to go ahead and do sheet image dot get RGB. Now this is a method in buffered image that allows us to get the RGB at specific points, right? Size X, size Y, pixels. It's just a method. You don't have to worry about the parameters. Don't worry about these last two parameters. I'm not even going to explain those. This is 0x, 0y, and then the size, so the width and the height. And then this is the area you're copying it into, pixels. Now the reason we're doing it this way is we don't have to actually change the sheet image, right? We're not actually gonna like go in and change the stuff that's in the original sprite sheet. We're just getting information from it. So if all we're doing is getting information from it, why actually create a buffer? You know, why don't we just get the RGB in? That's all we have to worry about. Because what we're doing here is we're kind of getting the data, and we're getting it in a way that allows us, whenever we change pixels, that changes something in the actual image. Right now, all we're doing is reading the data. So that's what we're gonna do. And also, wait, what? Hold on. Okay, yeah, sorry. I just making sure I was explaining that right in my notes. The reason that we got like the exact copy from the data buffer in render handler is because we wanted the pixels to be automatically updated. It's pretty much why we did that. But here we don't want that to happen. Oh, well, there's no reason for it to happen. So that's what we have going on right now. We're setting the pixels of array here of the sheet. And that's pretty much all we are doing so far. So maybe we want to go ahead and make a few methods here. Let's go ahead and do public int get pixels. And this is just going to be a getter and a getter to get the pixels from here. So return pixels. And then public buffered image get image, and that's going to return the image of the sheet. Just in case we need those methods, why not put them in? They're easy to make anyway. So what else do we have in our slide here? We have SpriteSheets holds an array. The sprites can be loaded based on image size parameters. Sprites hold an integer array of pixels for the sprite image and holds fields for the width and height of the sprite. So we have our sprite sheet. Now what we need is our sprites. So what we're going to do is we're going to make another method in SpriteSheet that is different from... let me just make sure I don't have like actual notes on this. No, I don't. Okay, that's fine. Hold on, now I can't click out. What is going on? Okay, it's fine. Anyway, so we're going to do this a little different than we have before. We're actually going to make a method that loads the sprites given the parameters. So I'm going to create a method called load sprites. Sprite size x and sprite size y are going to be the parameters. And for this sprite sheet, for example, both of those parameters will be 16 because the sprite size x for each sprite is 16 pixels, and the sprite size y is going to be 16 pixels as well. So that's why we're doing that. And also one other thing, I'm pretty sure, depending on what color you're using, this is the cyan color, which I used instead for my notes. So to fix that, what you can do is you can go and put this in tolerance mode. I can go ahead and just replace all those pixels with the pink one. So I just use Magic Wand to select all of those exact pixels, and then we select that hot pink color that we used. I think it was, which one did we use? Was it the, did we end up using this one? I forget. No, we used the other one. So if we go ahead and put, boom, then we've got our alpha set up correctly for that sprite sheet. So you can also use that cyan color though if you want as well. There's no reason why you can't do that for alpha. So anyway, back into SpriteSheet. Our load sprites method is going to load all these sprites into a sprite array. Okay, remember there was a sprite array. So that means we need another thing up here, a private sprite array. Oh, a private sprite array of loaded sprites. And that's going to be equal to null at the beginning. We can also just, well, I want to do it that way, and I'll tell you why in a second. So we're going to load sprites, and we're loading the sprites into that sprite array. So first of all, I want to actually create the loaded sprites. So loaded sprites is going to be equal to a new sprite array, just like we create any other array. Loaded sprite is a type sprite, and we want to go ahead and put this amount of sprites we want inside these two brackets here. And the amount of sprites we want is going to be size x, which is the size of the image, divided by sprite size x. And that's going to be multiplied by the amount of layers of sprites we have. Size y minus sprite size y. Okay? Now, the reason we are doing this is because we don't want actually an array of pixels here. We want an array of the individual sprites. We want to divide the size of the image by the size of the sprite. Is pretty much what we're doing here, to make sure our array is just as big as it needs to be to hold the sprites of the image. And also we're assuming that every single section of 16 by 16 has a sprite in it. And if it doesn't, you don't have to even worry about that sprite. It's going to load it, but you don't even have to use it. That's not a big deal. But one thing you're going to have to do for this is I would recommend concatenating all of your sprite sheets so you don't have a bunch of empty sprites that don't even really you're not using at all. So what we're going to do here is we're going to go ahead and use nested for loops, and I'll go ahead and get them started. We're going to use two nested for loops like we had before to go through the whole set of images. Instead of go through the whole sprite sheet is what I mean to say. So we're going to go through the whole sprite sheet, and we're going to have a separate variable to keep track of the current sprite that we are currently copying over. So sprite ID is another variable that we're going to have above these for loops. And yeah, so pretty much what we're going to do is we're going to copy the sprites down depending on, okay, so this is what we're gonna do. We're going to increase, this is going to increase every time by the sprite size. So sprite size y, and x plus equals sprite size x, okay? So this is increasing by the size y of every sprite and the size x of every sprite. And we're going to loop through pretty much every sprite that we have. And what we need to do here is we need to go ahead and tell our sprite to actually load here. So, well, also we want to do is we want to do sprite ID plus plus, because we're going to be increasing our sprite ID because we're now on the next sprite once we've done this. So now is the time where we need to actually create a sprite class in order to continue here. So let's go ahead and do sprite.java. And let's open that up. Now sprite.java is going to be actually a lot simpler. What we're going to do is we're going to create a public class sprite, and all this is going to hold is width and height of the sprite, and an integer array of pixels. Okay, that's actually all it's going to do. So the constructor for sprite is going to take a sprite sheet, a start x, a start y, relative to the sprite sheet, a width, and a height of the sprite. Okay. So now we're going to set the width of the sprite fields that we have up there. So width and height of the sprite is set. And then we want to set the pixels equal to a new integer array width times height, like we did before. So what we're doing is we're creating our sprites, right? We're creating our sprites from the sprite sheet. Now the cool thing is we have this SpriteSheet.getImage method, right? Now remember that quick little buffered image method I showed you, which was get RGB, the start x and the start y, the size x and the size y. Well, we can use the same exact thing over here to copy that specific section of the image. So what we can do is we can actually do sheet.getImage.getRGB, pass in start x, start y, width, height, the pixel array, and then those are what those last variables are going to be. I'm not even going to, like, if you want to figure out how those work, look at the Java doc. I'm not going to explain what these two things do. It's pretty much buffer size. Just don't even worry about it. We have the start x, start y, width, height, and pixels, okay? And yeah, that's actually just going to get that section of the sprite sheet for this specific sprite, all right? So we're making things a lot more organized for ourselves. And just for the heck of it, why don't we go ahead and make another, let's say we just want a sprite, right? Let's say we don't actually have a sprite sheet. All we want is to get this specific sprite here, like that grass tile. Why don't we just make that possible, right? Public sprite buffered image width equals image dot get width. Height equals image dot get height. Pixels equals new integer array width times height. And image dot get RGB 0, 0, width, height, pixels, and then 0 and width again. So we're getting, this is if we just have one image with just one sprite on it. And one other, we actually have to import buffered image because we've used buffered image in here. So let's just go ahead and copy that over from SpriteSheet, import java.art.image.bufferedImage. So yeah, that is our sprite class. Now there are a few more things that we're going to need. It's just some getters. So public int get width. This is going to be a method that returns the width of the image. And then we're going to go ahead and copy this 2 times. We're going to have get height, return height, and then get pixels, return pixels. Those are our get methods. And I'll get all of those fields that we have up there. And the reason we have getters, right? The reason people, if you're new to programming, you might be, why don't we just make these public? Well, we don't want anybody to change these on the fly, right? We want people to have access to getting them, right? But we don't want people to actually change them and set them. You can set width and set height. That's another, like getters and setters is kind of the terminology here. But all we're doing right here is all we really want is getters, right? So that's what we're doing. And yeah, that's pretty much our sprite class, right? We got this up here to load a specific sprite from a specific part of a buffered image given by a specific sprite sheet. And then down here, we have just a normal sprite without a sprite sheet, right? So now we can go back to sprite sheet, and all we have to do is tell the sprite where to start, right? So we can go ahead and figure out what part of the loaded sprites area we want to access. And that's just going to be the sprite ID, which we have up here. Is going to be equal to a new sprite. Now, if you remember what the parameters were, I'm going to go ahead and just copy those down. I like doing this whenever I'm figuring stuff out. Just copy down the constructor, and we can fill it in, right? So we'll just put a semicolon at the end. So we're passing in the sheet. The sheet that we're passing in is just this, right? The this property in Java just passes in an object of itself into whatever parameter. So we're passing in this because this is this sprite sheet. So, and then x is going to be the start position. Y is going to be the start Y, and the width and height is going to be sprite size X and sprite size Y. Okay? So that's it. We've actually loaded all of our sprites into an array. The only thing we have to do now is actually get those sprites. Let's make sure that compiles as well. Return pixel in sprite.java. Should be return pixels, not pixel. And this is actually going to be an integer array, not an integer. Because I think I copied that down and didn't change that. So my bad, make sure you fix that in sprite.java. So yeah, now getting sprites. Now what I want this to be is, let's say we have our sprite sheet here. I want to have two methods here, or two parameters is what I meant to say. In our sprite sheet, I want public sprite, because this is going to return a type sprite, get sprite int x, int y. Okay? Now this is going to be the x and y coordinate of the sprite. So this sprite up here, this little left roof tile right here, this is coordinate 0, 0. This is coordinate 1, 0. This is coordinate 2, 0. This is coordinate 2, 1. Okay? So this is the y change, this is the x change, that's 0, 0. That is width minus 1, height minus 1. Okay? That's what we're dealing with here. Okay? So it is 0 based. Oops. Oh, I didn't even know this existed. Attach files. Weird. Okay. Anyway, so pretty much it's the same sort of stuff we did before. So first of all, we need to make sure that we have our sprites loaded. So what I want to do to make sure this is true is have a boolean called sprites loaded, and this is going to be set equal to false. And once we call load sprites, we're going to set sprites loaded equal to true. Okay, so once all of this is done, sprites loaded is going to be true. Now our get sprite is going to check that sprites loaded is true. So if sprites are loaded, continue. Else, we're going to do a print line saying cannot get a sprite if we have no loaded sprites. I don't like speaking this kind of tense. So sprite sheet could not get a sprite with no loaded sprites. So it's like, you know, it makes a little bit more sense than what I said. It's like, we can't get a sprite if you don't know loaded sprites. That's pretty much what I was saying before, but this makes a little bit more sense for programmers. So if the sprites are loaded, then the sprite ID is going to be equal to x, and ready for this, x plus y times width. Ready? You know what the width is? Size x divided by our sprite size x. So actually we need to save sprite size x. So private int sprite size x. We're gonna do this dot sprite size x is equal to sprite size x. Okay. So we've set that private integer, so we can just do size minus sprite size x. Okay. So x plus y times width. This is like the biggest thing that we've been doing. So x is the offset. This is how many levels we have, right? So size x divided by sprite size x, because we're not dealing with pixels here. We're dealing with the individual sprites. And there we go. Oh, that's the sprite ID. Now we just have to return it. So if sprite ID is less than loaded sprites. Actually, all right, so what we're pretty much doing here is we're going to return loaded sprites of sprite ID, okay? Which is what we have here. But I just want to make sure that we're not out of bounds, because it's very easy for us to give something for someone to pass in something that's not in the sprite sheet. So if sprite ID is less than loaded sprites dot length, we want to do this. Remember, this is 0 based. That's why we're it's not less than or equal to. Else, we just want to just get rid of these brackets and just do system.out.println sprite ID out of bounds, or sprite ID of sprite ID. We'll actually just pass in. We'll make a very descriptive error here. So sprite ID of whatever the sprite ID of there is out of range, is out of the range with a maximum of loaded sprites dot length. With a length of, we'll do a length of. Out of range with a length of loaded sprites dot length. So that's a very descriptive error. And we can actually get rid of the brackets here as well. And then put a return null at the end, because that's if everything didn't work. Need to return something, so we're returning null. And we can get rid of the brackets here as well. And there we go. Now we've got a very organized method going on here. If the sprites are loaded, we're going to set that sprite ID equal to x plus y times the width of that sprite as far as in the sprite array. So we're dividing that by the actual sprite's width, because we're not dealing with pixels, we're dealing with sprite coordinates. So there we go. And that should be it. We now have sprites. Oh, I need a semicolon there. We now have sprites and sprite sheets. All we need to do now is go into render handler and make a public void render sprite method. It's going to take in a sprite, an x position, a y position, x zoom, and y zoom. And all it's going to do is call the render array method. And it's going to do sprite.getPixels, sprite.getWidth, sprite.getHeight. That's the render height. The x position is still x position. Y position is still y position. X zoom is still x zoom. And y zoom is still y zoom. Okay? So we're being very efficient with our methods here. That is only just a one line for rendering sprites, because we've already got the render array method. And that deals with all the transparency and everything. So we are set. We've got render sprites set up. So let's try to implement this with the game now. So we currently have our test image. What if instead of the test image, we created that as a sprite? So test image equals load image grass tile. Now let's go ahead and just do private sprite test sprite, right? Now let's test the first part of the sprite, and that is just passing in a buffered image. So we're going to go ahead and do test sprite equals new sprite test image. Okay, right below this test image line, we're going to do that. So we're passing that in. And then down here, instead of rendering the image here, we're going to do renderer. Oh, if I can spell it, renderer.render sprite test sprite 0, 0, 5, 5, like we passed in before. That's the x position, the y position, the zoom x, and the zoom y. And that now rendered a sprite, which doesn't look that much different from the image, but it's going to make a world of difference for us. So we're rendering a sprite now. Now let's try something different. Let's go ahead and try loading a sprite sheet. So we're going to have our private sprite sheet. Let's call it sheet, because what other type of sheet are we going to have here? And we need the sheet image, so I'm just going to go ahead and do buffered image, sheet image is going to be equal to load image. I'm going to call the load image method we made before, and just load the tiles1.png image that we have in our workspace right here, tiles1.png. I just realized I can zoom in to make your lives easier. I'm sorry that I did not do that earlier. My bad. So anyway, we've loaded that sheet image. Now we need to go ahead and call the constructor. So we're going to go ahead and set sheet equal to a new sprite sheet. And like I did before, I'm going to go ahead and, well, actually, it just passes. We just need one thing. So that is the sheet image that we're passing in. Okay. And now what we want to do is we want to actually load the sprites. We're going to do sheet.load sprites 1616 because that's the size X of our sprite and the size Y of our sprites. Sheet image. Buffered image, my bad. Not buffer strategy. Cool, so now we know it's loading the sheet, but we're not actually seeing if that works. So why don't we try getting a sprite from our sprite sheet? So let's go ahead and set test sprite equal to sheet.getSprite on a 3-1. All right. That's whatever that sprite was. 1, 2, wait, so we had 3, 1, 0, 1, 2, 3, and then 1. So it was that little top part of that table. That's all that was. Let's try something a little bit different. Let's try 4, 1. Okay, so that's the wall. Now one thing I'm noticing is it's not doing anything with alpha right now, so that's concerning. Let's go back to render handler. So 0xFF00DC was what we used. Let's go back to paint.net. I didn't expect this error, to be honest with you. So we'll do a little bit of troubleshooting here. Let's go ahead and select everything and make sure that that is in fact the right color. FF00DC. Yeah, it looks like it is. Maybe it's because I need to do more F's at the beginning there. Okay, yeah. You need to do 0x. This is the problem is, in order to create this hex from what we copied down here, you need to do 0xFF first and then put in your the values. So 0xFF and then FF00DC. So now it's going to deal with that correctly. Oh shoot. So the reason that was working for rectangles because we actually physically set that to what we wanted it to be. So, yep, now we can get whatever sprite we want from our sprite sheet and render that onto the screen. Now that is pretty cool. Let's see if we can move on to something else or if I can find a good stopping point. I'll be back in just a second. Well, I think I'm gonna have to stop there for today. We've done quite a lot, and it's going to take. Well, the next thing we have to do is going to take quite a while, so that's a pretty good stopping point. So yeah. Unfortunately, I don't have much of a challenge for you this week, but why not mess around with this? Why not mess around with the rectangles, the transparent and stuff, and the tiles and the sprites? Maybe you can try and load specific sprite sheets. In fact, you know what you could do? If you go on my website, you could try dealing with sprite sheets with padding. I don't think I'm actually going to give you the do this, but if we go into our assets here and public domain assets, the sprites and the roguelike, the sprite sheet actually has padding between every pixel. Every sprite is what I meant to say. So why don't you try and deal with that if you want to use this sprite sheet for some reason. I mean, it's giant, and I mean you have pretty much everything you'd need for a roguelike RPG in this sprite sheet. Try to implement some sort of padding. There's a 1 pixel padding between every sheet. Every sprite is what I mean to say. So maybe in the load sprites method, you can figure out a way to deal with that. It'd be relatively simple. Yeah, that's a challenge. Do whatever you want. I mean, you're starting to get actually some sort of a game here. Like we have the graphical capabilities to make a 2D game at this point. You have a camera that can move around. Maybe you can start moving the camera around. Do whatever you want. I'll try to make another video quickly so we can move onwards and get into some more gameplay, some actual keyboard presses and mouse movements, stuff like that. But anyway, guys, thank you for watching, and I will see you next time.